Hi guys, welcome back. This is part 3 of solving a linear system by elimination using addition. And we're going to do it again through an example. Find the solution for the system 4x plus 2y equals 10 and x minus y equals 13. So you can see when we go to do the addition here that nothing is eliminated by adding these two equations together. 4x plus x is 5x, 2y minus y gives us y, and 10 plus 13 gives us 23. So nothing is eliminated, so we're no closer to solving this system by just adding. So based on what we did in part 2, maybe we could change all the signs. Maybe that'll help. Let's see. So if we change x to negative x, minus to plus, and 13 to negative 13, and we add them together, let's see, 4x minus x equals 3x, 2 y's and 1 more y's is 3 y's, 10 minus 13 is negative 3. Hey, we're still in the same boat. We haven't gotten any closer to solving this solution. So what can we do? Well, here's another technique, guys. If you notice, what we're always trying to do to eliminate, we're trying to get one of these two coefficients in this equation to be the same number but the opposite sign. The same number but the opposite sign. So when we add them, they disappear. Now we had something at the beginning of the year. What do we call that? I'm trying to remember. There was a name. Additive inverses. That's right. That's what it was called. If we have 2y and negative 2y, 2 and minus 2 are additive inverses. When you add them together, you get 0. Okay, so what we did, let's go back and take a look at what we did here. We multiplied the second equation by 2. Why would we do that? Well, if we multiply everything in the second equation by 2, everything, we get 2x, because 2 times x is 2x. We multiply the second, we have 2 times y is 2y, and we didn't change the sign. The sign is still the same. Okay, and 2 times 13 is 26. So we multiplied the entire equation, the entire second equation by 2. Now, if you look, why did we do that? Well, now we have plus 2y and minus 2y. Those are additive inverses of each other. So when we add them together, they become 0, right? The y's get eliminated, okay? Now, so if the y is eliminated, now we only have one variable to deal with. 4x plus 2x is 6x, 10 and 26 is 36, and we now we can solve the problem for x. So we divide both sides by 6 because we want the coefficient of x to be 1, and we end up with x equals 6. So we have half our answer. Now that we have half our answer, we're on our way. We just finished what we've been doing the last few days, right? So we can substitute in our x in either equation. So I picked the red equation, 4 times 6 plus 2y equals 10, and that gives us 24 plus 2y equals 10, and now we can finish solving for y. So since we have 24 on one side and 10 on the other side, and remember those are both constants, we want to get the constants together, so we're going to subtract the 24 from both sides, and that gives us 2y, because that's all that's left on the left-hand side of the equation, and 10 minus 24 is 14. Now to get 1y, remember we have 2 y's there, we only want 1. We divide both sides by 2, and our solution is y equals negative 7. So we've got both sides of the solution. We have our x equals 6, our y equals negative 7, and now we can check. Since we used the red equation to do our work, let's check using the blue equation. So 6, our x, minus negative 7, okay, and minus negative becomes plus, right? We know that. So 6 plus 7 equals 13. 13 equals 13, so it checks. Now, if you want, it's not a bad idea to check the other equation too, just to make sure we didn't make any mistakes and we got everything right. So let's check the other equation as well. So 4 times x, x is 6, plus 2 times y, y is negative 7. 4 times 6 is 24. 2 times 7 is 14, but it's a minus because we have that negative there, so we put the minus in. 24 minus 14 is 10, and we can see 10 equals 10, so we're good to go. Now, this is only one of several ways we can solve this system. Let's look at another way. Trying to eliminate y, just like we just did, we're going to find another way to eliminate the y variable. So let's take a look at this again. Okay, how did we eliminate y before? We multiplied the second equation by 2, and that gave us a minus 2, and we have that plus 2 there, so those are additive inverses, so we got rid of our y's. Now, can you think of another way we could get rid of our y's without multiplying the blue equation by 2? Let's see. So if I write that down, hey, wait a minute. This has a 1 in front of it. We don't see it, but we know that that's 1y, right? The coefficient there is 1. I wonder if there's any way I could turn this y into 1, to have a coefficient of 1. Let me see. Maybe if I... What if I divide by 2? Let's see. 4 divided by 2, 2 divided by 2. Yeah, I can divide everything by 2. I'm allowed to do that, because as long as I do the same thing to every part of the equation, I'm allowed to do it. I didn't change the problem at all. So our first term, 4 divided by 2 becomes 2. 2 divided by 2 becomes 1, so that's 1y, 2 x's, and 10 divided by 2 becomes 5. So I rewrote it by dividing everything in that first equation by 2. Now, we're not going to do, remember, we only work on one equation. All right, we leave the other equation the same way it was, so let's bring down the blue equation now. And when we add them, what do you notice? The y and the negative y, they are additive inverses of each other, so we've eliminated the y again. Okay, and then 2x plus x equals 3x, 5 plus 13 equals 18. We know when we divide the two sides by 3, we end up with 6, which is exactly what we had before for x. We got 6, we got the exact same x. Okay, so once again, what did we do? Okay, the first time we multiplied the second equation by 2 because we wanted to get a minus 2 here. We have a minus in front. We have a 2 plus 2 on top, so we multiplied everything by 2. This time, what did we do? We divided the top by 2. Why? Because we wanted to get a 1 in front of the coefficient, or just have this coefficient be look like that, just a y. Because remember, when there's no coefficient number in front, we know it's 1. All right, and then we add it. We can see the y's get eliminated, and we solved for x again, and then we can finish the problem. Now, what if we wanted to eliminate the x variable instead of the y variable? Could we do that? Well, let's take a look at it. So this time, we're going to try and eliminate the x variable instead. So if we look at the coefficient of x here, it's 4. If we want to get rid of x, we want this term to be a negative 4. So what should we multiply by? Negative 4, right? Because 4 minus 4 gives us 0. So if we multiply everything in the equation by 4, everything by negative 4, right? Okay, negative 4 times x becomes negative 4x. Negative 4 times negative y, negative times a negative becomes a positive, and we got the 4 in front, 4y, right? And we also have to do negative 4 times 13, which is negative 52. So we have multiplied everything in the blue equation by negative 4. And you can see right away, we have additive inverses now, 4x and negative 4x. That's going to eliminate our x values. Now we can solve for y. So in this way, we're solving for y instead of solving for x. Kind of opposite of what we did with the last two methods, right? So 2 plus 4 equals 6y. 10 minus 52 is negative 42. We divide both sides by 6 to get y. To get 1y, and that gives us negative 7. And you can see, once again, the same answer that we got when we first started this, right? So the answer hasn't changed, but we've just used another method to do it. Okay? Now I want you to give it a try. So what you're going to do, guys, you're going to find the solution to each system. You're going to show your work. You're going to show your check. Here's the problems for tonight. 4 of them once again. Write them down on a separate piece of paper. Show your work, show your check, bring it to next class. We'll discuss it and we'll go over your questions. See you soon.